Hello everyone, welcome to our today's video lesson. In this video we'll see trigonometric ratios with right-angled triangles. In our previous video we have seen Pythagoras theorem with right-angled triangles, and we defined right-angled triangles as triangles in which one of the three angles measures 90 degrees. So those triangles are said to be right-angled triangles. So we defined right-angled triangles in our previous video. So again we'll see the same right-angled triangles in these trigonometric ratios. So a trigonometric ratio describes the relationship between the size of one angle and the length of two sides in a right-angled triangle. So as you can see here, it says trigonometric ratio. It describes the relationship between the size of one angle and the length of two sides in a right-angled triangle. So if we have given a right-angled triangle, the relationship between one of the three angles and two sides of the given right-angled triangle, so that relationship is termed as trigonometric ratio. Trigonometric ratio. So in this section we'll see, as you can see here, it says in this section we'll see three trigonometric ratios. We'll see three trigonometric ratios. So what are these three trigonometric ratios? These three trigonometric ratios are, the first one is sine. As you can see here, we have the first trig ratio, which is sine. In short, you can write it as sine, S-I-N. And the second trigonometric ratio is cosine. In short, you can read or write it as cos. And the third trigonometric ratio is tangent. And in short, you can use this tan. So that we have these three trigonometric ratios. These are sine. The second one is cosine. And the third one is tangent. So we'll see these three trigonometric ratios. Alright, so as you can see here, it says the three sides of a right-angled triangle have special names. As I said, we have defined right-angled triangle. So in a given right-angled triangle, we have three angles and three sides. But here in this trigonometric ratio, these three sides have their own special names. What are these special names given for these three sides of a right-angled triangle? They are as follows. Okay, now look at this right-angled triangle. So in this right-angled triangle, as you can see, the first one, it says the adjacent side is the side that joins both the angle and the right angle. Now, which angle is given? The first thing we need to identify which angle is given. As I said, we have three angles. This angle is the right angle, and this one is the first angle. You can say 1, and this one is 2. So you can use any symbol to name one of the angles. So after naming one of these two angles, then using the relationship between these two, one of the two angles, you can name the three sides of this right-angled triangle. For example, let us take this angle and let us name it theta. This is angle theta. So this is a symbol that we are using to name this angle. So we name it as angle theta, or you can name it as angle X, angle Y, or any letter. You can use any letter to name this angle. Now, we will name the three sides of this right-angled triangle referring this angle. Now we have given this angle, we use this angle, not this angle. If you give this angle, we use this angle. But for the time being, we have given this angle theta. So using this angle theta, we name the three sides of this right-angled triangle. Now let's start from the first side. The adjacent side, as you can see, it says adjacent. The adjacent side is the side that joins what? Both the angle. Which angle? Angle theta, the given angle theta here, and the right angle. Where is the right angle? The right angle is here. So look at now, here we have right angle, okay? Here we have the right angle and angle theta is here. So the side which joins the two angles, this angle, right angle, and angle theta, we call it adjacent side. So name this as adjacent, or you can use letter A. So this letter A stands for adjacent. So this is the adjacent side, the side which joins the given angle theta and the 90-degree angle or the right angle. Now let's go to the second point. It says the opposite. Now we have opposite side. In the first part we have seen adjacent. Now here opposite side. The opposite side is the side which is opposite to the angle. Which angle? The given angle theta. Here we have given angle theta. So the side which is opposite to this angle theta, we call it opposite side. So which side is opposite? This side is opposite, or which is opposite to the given angle theta. The given angle theta. Alright, what is the third point? The third point says the hypotenuse. Actually, we have defined hypotenuse in our previous video. Hypotenuse means the longest side, or the side which is opposite to the right angle. Which side is opposite to the right angle? This side, the longest side. So this side is said to be hypotenuse of the right angled triangle. So name this as H, which stands for the hypotenuse. So we have now three sides. The adjacent side, the side which joins the right angle and angle theta, we call it adjacent side, and opposite. Opposite is the side which is opposite to the given angle theta, and hypotenuse H, the third side. Hypotenuse H is the longest side, or the side which is opposite to the right angle. Now we have already given the three special names for the three sides of this right angled triangle. Now using the above definitions, that means the definitions given for the three sides, these three sides, special names, opposite, adjacent, hypotenuse, we can write the three trigonometric ratios. Which are these three trigonometric ratios? The sine, cosine, and tangent. How? We'll see. Okay, so as I said, we have already given the three special names for the three sides of a given right angled triangle. Okay, now we use the same thing. Once if you have given the angle, then easily you can name, or you can give special names for the angles. Now which angle is given here? The angle is not given, but you can choose any angle. This is the 90-degree angle, which is the right angle, 90-degree angle, the right angle. But the other two angles, this angle and this angle, you can choose one of the two. So you will get the same relationship here, the same relationship here. You can choose this angle or this angle. But in our previous right angled triangle, we took this angle. So that now let us see this one. You can name it as theta or x or y, as I said. But here we are using theta. As you can see here, theta is used. Here again theta, here again theta. So that let us name this angle as angle theta. So as I said, you can name this as angle theta, this one, and then you can check whether it is right or wrong, the relationship that we have given here. Okay, now using this theta, let us name these three sides, or let us give the special name for these three sides of this right angled triangle. Okay, how can we name? Look, this is angle theta. So the side which is opposite to the given angle is the opposite side. So that here we have O, which is the opposite, and the side which joins the angle, this angle and the 90-degree angle, we call it adjacent. So that this side is A, which means adjacent, and again the hypotenuse, or the longest side opposite to this right angle, we call it hypotenuse, which is H. So after giving special name, these special names for the three sides of this right angled triangle using angle theta, as I say, don't forget, you can name this as theta, and then you can name again these special sides of this given right angled triangle. Later you can check whether the relationship that we have given here are right or wrong. Now how can we define the sine of this angle theta? sine of theta is defined as opposite over hypotenuse, or the opposite side divided by the hypotenuse. So for this theta, sine of this theta is opposite the length of the opposite side. That means the length of this side divided by the length of the hypotenuse. So if you have given the hypotenuse, the length of the hypotenuse, and the length of this opposite side, so easily you can determine sine of this angle theta. The second one is cosine. Cosine of theta, or in short you can say cos theta. Cos theta is defined as adjacent divided by hypotenuse. Adjacent, which is given by A, this side, divided by the hypotenuse. So if you have given the length of this adjacent side and the length of the hypotenuse, by finding the quotient or by dividing adjacent to the hypotenuse, so easily you can determine the cosine of this given angle theta. The third trig ratio is tangent or tan theta. Tan theta is defined as opposite over adjacent, or opposite divided by adjacent. Opposite is here, this side, which is opposite to the given angle theta, which is O, and divided by A, which is the adjacent side A. So tan can be defined as opposite divided by adjacent. So in short, you can write sine theta is equal to O divided by H. That means opposite divided by hypotenuse. And cosine of theta or cos theta can be defined as A, adjacent, divided by H, the hypotenuse. And tangent, tan theta of a given angle can be defined as O, the opposite side, divided by A, the adjacent, divided by A, the adjacent. So as I said, don't forget, name this angle. If you want theta, X, Y, or any symbol you can use, and then name this one. Later you will see the relationship that you'll get from this angle, theta or beta, or you can use X or Y. So these are the three trigonometric ratios and their definitions using the three special names of this given right-angled triangle. Right-angled triangle. Now, after having this, let's go to example 1 and let us see the example. So look at the example. The example says, level the sides of the following right-angled triangles. Level the sides of the following right-angled triangles. Now, to level the sides of these given right-angled triangles, our first step should be which angle is given. Which angle is given? As you can see, which angle is given here? This angle is given. Look at here. This angle is given. Because the arc here, the arc shows that this angle is given. Because we don't have arc here. No letter is not given here. That means the arc. This arc shows that we have given this angle, but this angle is not given. For this one, it's known. The degree measure of this angle is 90 degrees, or we have right angle here. So we use this angle to level the sides of the right-angled triangles. The sides of the right-angled triangles. So as you can see here, we have given this angle. So for this angle, what is this side? What is this side? And what is the third side? Now let's start from the opposite side. As you can see, the angle is given here. So the side which is opposite to that particular angle is opposite side. We call it O. And this side, the side which is adjacent to this angle and this angle, or which joins these two angles, the given angle and the right angle, we call it the adjacent side A. And the third one is the side which is opposite to the right angle, or the longest side in right angled triangle is the hypotenuse. So we'll have H here. We'll have H here. So these are the three sides with their special names for the first right angled triangle. Now let us see the second one. So as we did for example A, in this example B, again this angle is given. As you can see, this is the arc. The arc shows that this angle is given. This angle is known. It is right angle, the right angle for this right angled triangle, so that the given angle is this one. So using this angle, let us give the special name, or let us label these three sides. So as we did for A, the side which is opposite to this angle is the opposite side. This one is O, the opposite side. And the side which joins the two angles, the right angle and the given angle. So this side is said to be adjacent, A, the adjacent side, and the third side which is opposite to the right angle or the longest side in any right angled triangle, call it hypotenuse. So we'll have H here. So this is the way of labeling or giving a name, special name for three sides of a given right angled triangle. So easily you can name or you can give special names for the three sides of any right angled triangle. Once if you have given one of the angles, so easily you can name the three sides. You can name the three sides. Okay, after having this again, let's proceed to the second example. That is example 2. Look at here. The example says, label the sides of the following right angled triangles and write the three trigonometric ratios. So the first step is we label the three sides and then later we write the trigonometric ratios, So as you can see in example A, which angle is given? Look at here. Look at this angle. Because there is arc, we have given an arc here. That means this angle is given. So once if the angle is given, so the opposite side, we call it O. Here we have O. And the side that joins the right angle and this given angle, we call it adjacent. So this is A with 8 units. And the other side, it is the hypotenuse, which is opposite to the right angle, H. Okay, so after this, we'll see their trig ratios. How? First, let us finish A, B, and C. Then we'll see the remaining part of the solution. All right. Again, here B, we have given this angle. The side which is opposite to this given angle is O. And this side, it is adjacent. Now after this, easily you can name the three sides. And this opposite to H, I mean the right angle, the longest side, it is H, or the hypotenuse of the right angle. And the third one, we have given this angle. As you can see, the arc is here. So this angle is given. That means the side which is opposite to that given angle is O with 15 units. And this one is adjacent, A, the adjacent side. And the longest side is the hypotenuse, H. Okay, we have already labeled the hypotenuse, the opposite and the adjacent sides of the examples given in A, B, and C. But the question is not only labeling the sides of the given right angled triangles, but we are asked to write again the three trigonometric ratios. So let us see the remaining part of the solution. So solutions, the first A, sine is defined as opposite over hypotenuse, opposite divided by hypotenuse. But which one is the opposite and which one is the hypotenuse here? The opposite is the side which is opposite to the given angle. As you can see, the given angle is here. This is the angle. So the opposite side is 6, and the hypotenuse means the side opposite to the right angle, which is 10. So for sine theta, we have 6 divided by 10. So as you can see here, sine theta is equal to 6 divided by 10. And for cos theta, cosine theta means adjacent divided by hypotenuse, A divided by H. But which side is adjacent to the angle? For this angle, as you can see here, the angle is given here. We have given the angle here. So for this given angle, the adjacent side is the side which is 8 units. And again, the hypotenuse is 10, which is the opposite side to the right angle. So we have 8 divided by 10. For cosine or cos theta, for this angle theta, that is cos theta is equal to 8 divided by 10. And for tan theta or tangent, defined as opposite over adjacent. So the opposite side, easily you can, once if you have cosine and cosine, so from this sine and cosine, because for sine we use opposite and hypotenuse, for cosine we use adjacent and hypotenuse. So all the three sides are used here: opposite, hypotenuse and adjacent. So by combining these two, easily we can determine tan of a given angle theta. So tan theta is opposite divided by adjacent. What is the opposite side? Here it is 6. So we have 6 units divided by adjacent. Where is adjacent? Adjacent is for cosine, that is 8. So 6 divided by 8. Okay, now let's see this B. 2B sine theta. The same, sine theta means opposite divided by hypotenuse. But let's go back and then see which side is opposite and which side is adjacent. So as you can see here, for this given angle, this is the angle, given angle is here. So the side which is opposite to this one is 12 units, and opposite means the side which is opposite to the given angle, and hypotenuse means the side which is opposite to this right angle. So that side is the hypotenuse, which is 30 units length. The length given by 13 units. So that for this, sine is opposite divided by hypotenuse. That means 12 divided by 13. 12 divided by 13. So we can go down here and then check. Sine theta, as you can see here, opposite divided by hypotenuse. So the opposite is 12 units and the hypotenuse is 13 units. Okay, then cosine. How can we find cosine? Cos of theta, a given angle theta, it is adjacent divided by hypotenuse. So which side is the adjacent and which side is the hypotenuse? Alright, now let us see. The adjacent side for this angle, the adjacent side is the side which is given by 5 units, and the hypotenuse is the side which is opposite to the right angle, which is given by 13 units. So cosine of this angle theta can be easily defined as adjacent divided by hypotenuse. The adjacent means 5 units and the hypotenuse 13 units. So as I said in example 2a, once if you have sine and cosine, by combining these two trigonometric ratios, easily we can determine tangent of the given angle theta. So tan theta is opposite divided by adjacent. The opposite is here 12 units and the adjacent is here 5 units. So that tangent of theta or tan of theta is 12 divided by 5. 12 divided by 5. Okay, now let us see 2c. Example 2c. 2c. Here in example 2c, we have the same relationship or the same definition is given to sine theta, which is opposite divided by hypotenuse. As we did for example 2a and 2b, sine theta here in 2c is opposite divided by hypotenuse. So let's go back to example c. Then let us see which side is the hypotenuse and which side is the opposite. So as you can see here, the angle, the given angle is this one. So which side is opposite to this? That is the 15 units side, and the opposite, which is opposite to this one, the opposite of this right angle, our hypotenuse, that is the 17 units. So that opposite divided by hypotenuse is the sine of this given angle, the sine of this given angle. So that sine of theta, that given angle theta, is opposite divided by hypotenuse. The opposite side is 15 units and the hypotenuse is 17 units. For cosine, cos theta, adjacent. Adjacent means the third side. The remaining side, the length is 8 units divided by the hypotenuse, which is 17 units. So as we did in example 2a and example 2b, tangent, easily by combining the two, sine and cosine, tangent can be defined. So the definition which is given for tangent is opposite over adjacent. What is the opposite here? 15 units. The adjacent is 8 units. So that tan of theta, for that given angle theta, tangent can be defined as 15 divided by 8. So for these three examples, 2a, 2b and 2c, our angles for 2a, 2b and 2c, theta is given by, this is the angle, so that our theta is this angle. Again, for example 2b, this is the given angle, our theta is this one. Okay, so for 2c again, the angle is this one, so this is our theta, because we define the trig ratio sine, cosine and tangent using theta in example 2a, 2b and 2c. So for any right angled triangle, once if you have the three sides, and then if you have given an angle, so that easily by using the trigonometric ratios you can define tangent, sine, cosine, plus once after having one of the angles you can label or you can give the special names for those three sides of a given right angled triangle. Here we have assignment. This is the third assignment. I hope you did the first two assignments and then you submitted to your parents those two assignments, so you will do the same thing. But before doing this assignment, you have to practice, you have to do and then check whether you did the questions in the right way or not by referring the examples that we did in example 1 and then example 2. Following the same steps, you can do these two questions. So the first one is labeling, as we did in example 1, so that you will label the three sides. That means using the given angle. The given angle here is this one. Question number B, the angle is given here, and question number C, the angle is given here. So using these angles, you label the three sides as adjacent, opposite and hypotenuse. And in this question number 2, you are asked to label. The first step is you label the sides. Then after that, you write the three trigonometric ratios for each right angled triangle that you are given in A, B and C. So this is what I have for today. See you in the next video.